this is Yong Wen. Today is August 19, 2020. In today's video, I'm going to go through the updates on research items since the past week. As you can see from the Gantt progress bar, there are two items in the stack. For the first one, the estimated progress is about 3%, and the same applied to the second item to work on the deep learning workflow. So let's get into the detail. For the first item, to extend the survey to the journal version, I've already wrapped up the first version of the paper, and I'm mainly work on the section 5, which is going to cover the goals and the requirements and challenges of the workflow management system, as well as the trinity of the workflow, AI, and big data in the section 7. So I think it's good time to have Dr. Liu and Dr. Che to review the paper for further modification. So I believe it's not 100% perfect, but I already spent some time to refine it to the best I can so far. So hopefully we can get a better one, much better one after both advisor or Dr. Liu and Dr. Che have time to review and modify. So this is the first item. For the second item, to work on the deep learning workflow. As I discussed in the last video, I tried to explore the CUDNN library since the past week. So I think this is a very good opportunity to look into the CUDA library, which is built for the neural network. So I think this is a very good tool, since if you take a look at the CUDNN documentation, so let's go to the documentation. You will see tons of methods that is required, that is available under the CUDNN documentation. So if we are going to try to beat up some existing work, for example, in the role detection, we have to implement like the batch normalization. We need to implement the back propagation. We need to implement the momentum, a lot of method or techniques. So I think this is a good way to start. Maybe I need to, first thing is to understand how to utilize the breaks. And so each of the method can be seen as a break. Maybe after I know how to use them, I can build up big house, and that can save us a lot of time. We don't need to write single method one by one, but still very big work, huge workloads, I think, if I need to understand most of them and try to utilize them correctly. So I think that's something I need to spend time afterwards. And also I found some code online which is implemented CUDNN, the new network implementation based on the CUDNN online. Basically that's some code from the GitHub. So basically this is implementation on a LeNet. So LeNet is also known as a very basic neural network. I tried to download this code. You can see this is a pretty old one, and I tried to download this code and config in my local environment. So as far as right now, but before that, I hope to mention I need to install the CUDNN separately, even though I've already installed the CUDA before. So I have to download the CUDNN and then copy the correct files under the CUDA folder which I had before, and basically I will copy some files into the include folder. I need to copy some into the bin folder, as well as some in the lib folder. So these three folders will be added with few more files, and in order to use the CUDNN. And furthermore, I need to add this to the environment variable of the Windows 10. So that's how we can utilize the CUDNN properly. But after I try to build the project after I set the correct environment to the CUDA DNN to the 10.2. I believe that's the version I have right now. I try to build this project, but I still get some errors. basically I get errors, for example, like the methods are undefined for this moment. So what I believe is this method has been obsolete since a newer version of the CUDNN, because the project used was 7.6. That's pretty old one. Current latest one is 11.0, and what I have is 10.2. So what I found on the website, if we take a look at the documentation, one of the documentation says, for example, here I have the method says the convolution forward preferred fastest. So this is a method to sign the algorithm to do the convolution method or technique. So basically we can have several algorithms to choose. We can use FFT, and we can use a fastest, we can use some other method. For example, we can save the space if we have a kind of space limited environment. So this is how we can define different algorithm in the 7.6 version. But however, in the latest, since version 8, this method has been obsolete. So you can see that this method is in the list that has been removed since version 8. So the first thing is either I can try to configure a version, CUDNN version and CUDA version of the 7.6 in my local and try to run the code, or I can try to convert the code into the latest version, maybe like the 10.2 or 11.0. So that is, I think maybe the later way is better, because since we're utilizing the CUDNN in today's version, so I think it's better to keep up with the latest version. So I will try to read the code, understand the code, and try to refine the code according to the documentation I have for the CUDA CUDNN. So basically there are a lot of things to go through, and there are tons of methods to look up. So I think this is very good. And furthermore, I believe this is a very big website and contains a lot of content. So the searching speed is quite slow, and the open speed is a little laggy. So that is one thing I hope to mention. So this is CUDNN I'm currently working on to explore and try to build up the neural network based on the CUDNN plus the CUDA. So this still be the direction I think that is good to move forward. So I think that's pretty much for the updates for today's video. And thank you so much for your time. I hope you enjoy. And until next time, happy coding.